Good evening guys, I'm Nachiketa and today I'll be talking about how to use shaders in Monogame. So first of all, I have this project and I'll quickly run it to show what it is right now. Then we'll go a little bit into code. So basically this is one of the textures from another game that I'm working on. So this is one copy of the texture that is drawing, and this is another copy. So I'm drawing two copies of the same texture. I'll quickly close it and show you how it is doing. So it is you must be knowing all this, because if you are opening a video of shaders, then obviously you know the basic things of monogame, right? So what I'm doing is, this is sprite batch.begin. I'm beginning the batch here. I'm drawing copy 1 and copy 2 in two positions. So now what I'll do, I'll go open a shader file, or maybe create a shader file. Actually I have the file ready, but what I'll do, I'll show you how to do that. So basically here is content.mgcb. Once you double click it, uh, this mgcb editor should open. So you'll go here, means we have to go here basically, or right click on content and add new item. Then there are two effects, so these are for shaders. You should not open this effect dot effects. You should always open sprite effect dot effects, because this is the one that is meant to work for 2D, and specifically 2D textures, sprites. So once you click create, it will create something like this, and it will name it some file.fx or something. You can rename it, and once you rename it, just like you build the images, you just click on rebuild and it will be building uh, the effects, that is the shaders. So now I'll quickly open this and we'll see what this does. So these lines basically, they define the compatibility. So these are some models, I do not know. Basically these are, I think it is saying that if it is OpenGL, the platform is OpenGL, because this is cross-platform project that I have opened. So if it is OpenGL, then there are shader model, vertex shader model is 3.0, or and the pixel shader model is 3.0. Similarly, if it is not that, so basically this applies for DirectX, then it is this vertex shader model and pixel shader model. Okay, and texture 2D sprite texture. So texture 2D sprite texture, uh, this is basically the variable where uh, OpenGL or DirectX will be writing the input texture. That is the texture that like if I'm using a texture, drawing a texture, this is where the texture will be stored. Then this is the sampler 2D. So this is basically the variable where it will be saving all the properties. So here only one property is written, and right now this is sufficient to understand. So it has told that save this variable, that is sprite texture sampler, with texture as a sprite texture. So this is how it is saving it. So basically we'll be using this variable from now onwards. We'll look ahead, and this is the variable for uh, vertex shader. So we are not talking about vertex shader, so we'll leave it for now. Okay. So this is where the pixel shader, means this is our main function. Basically we have to make our changes here to change how the sprite looks, or make changes into the output sprite. So first of all, before we go into that, we'll go into this class and see how we shall load this. So basically this is the line to load the texture. So I created an object called effects whitewash. Okay, so whitewash is my variable name. This is the class that I have to, like, just like texture 2D, this is the effect. So there is another class called sprite effect. Do not use this because I got a lot of errors once I used that. So make it effect whitewash, and then when you're loading also it will be effect whitewash, not sprite effect. Okay, uh, and this is the variable name in the, because this is in the root folder, you don't have to add the extension. Just like here, for texture you didn't add .png, so here also it will not be whitewash .effects, it will just be whitewash. Okay, and since this is in the root folder, it is directly just the name is sufficient. Okay, now we'll see how we shall apply this texture, this shader. So what I'll do, we will continue drawing the first one without any shader application for comparison, so that we can see the difference. Okay, and the second one, so basically we have begun a batch with some settings. Now we have to change the settings to draw the other images. So basically what we have to do, we have to first end the batch, end the previous batch. Okay, so it will flush this image into the screen, and then we'll start another batch. But this is just the default way of starting the batch. We have to define the shader effect here, or apply the shader effect here. It is very simple. Basically, if I keep the mouse here, you can see that there is that sort mode, means you can pass many optional variables: sort mode, blend state, and depth stencil state, rasterize state, and then effect. So this effect is what we have to target. So what I'll do, I'll just write the variable name that I have to target, and then give my shader name. Now we have begun it with the shader effect, and we are ending it here. Okay, so I'll just run it to see if this game runs smoothly, means without any problems. So if it is running, yes, it's running, and since it is running, we can go ahead and make changes to our shader. Okay, I'll also, I think it will be better if I just keep it on the side so we can see how. Okay, so basically what we'll do is, see, this is the shader basically. This is the texture that will be affected by the shader, the second one. So what we'll do, we will go ahead and first print the entire texture white. So how shall we do it? It's very simple. Basically right now, basically your texture is defined in a way like color, no, sorry, the return type. See here, the return type is float 4, so it doesn't save as color but float 4. So 4, and then there is R, G, B, and A. There are 4 variables. So this is the red component, this is green component, this is blue component, and this is alpha. Alpha is the transparency, and all of these have values between 0 and 1. So decimal values, float values. So what we'll do, white is 111 and alpha is 1, fully opaque. So what I'll do, I can't comment it like this, but maybe here I will return, because this is the return type, and then I'll just type 1111. So this return will not be reached because we are returning from the function before that. So what it should do is, basically it should make every pixel, because this pixel shader is called once for every pixel. So since I am uniform means returning the same value, that is white, for every pixel of the texture which I am drawing there should become white. So basically every pixel of this should become white when it is drawing under the effect of the shader. So I'll just restart this game, and here we go. So basically my texture was this big, the whole one, so all of that became white. Now what we'll do something interesting, more interesting. Even this was interesting because this is basically the same texture, but we have modified the shader, and that is the reason we are getting a different kind of result. So now what shall we will do is we will go into this texture. So this is basically the texture that we are drawing. So what we'll do is uh, we'll only make the opaque parts, that is the parts which are visible, we'll only make those parts as white. Okay, so I'll just escape this project. I'll go into whitewash, and what I'll do here, I will be saving this as a variable, float color. So this is the return color. Maybe you can write here return color. Okay, and then I'll be returning this color, return color. Here what I'll do is what I was doing earlier is return float 4 1 1 1 1. So if I do this, all the pixels will become white, but I have to do this only. This is the alpha component, that is the transparency. So what I'll do here, I'll check here if, oh, this is float 4, not float. If return color dot a is greater than 0.9 or is equal to 1, return float 4. So now what will happen, only if the alpha is 1, that is if it is fully opaque, then it will return this color. Otherwise it will be returning the default color of the pixel, that is transparent. So we'll just run this and see how it works. See, this working, right? Only the opaque color of the texture have been converted to white. Rest of the place is as it is. Earlier it was fully white, the whole texture. Now only this part is white. So now we'll do something else. What we'll do is, instead of making this white, we will be making, we will try to yeah, this red part, we'll be removing this red part and making it, or maybe we'll make this black, this one will make as black. Okay, so this is the last thing that we'll do, and I think you have some basic idea of how shader works. So I'll just, it is not fully red, it may not be fully red, it may be something like the red value will be greater than, because there is no other red other than this play and this close button. So the red value may be something like more than 0.5 when you check. So so now I'll make it transparent. If there is no, sorry, I'll make it black. So black is 0 0 0 and 1. Okay, but what will be the condition? This is, we have nothing to do with the alpha. We will basically go to R, that is the red value is greater than 0.5, and once we do that, means basically if the red value is greater than 0.5, then it will be making that red part as black. See, we got it. Okay. The white has also means the white has become invisible or merged with the black because white is 1111. So even in case of white, it is the R is still more than uh, 0.5. Okay, but this play has not disappeared. Maybe its R value is lower. We can try doing that. So basically, we'll do one thing right now. What I'll do now is I'll try to keep this X, this close X, intact. First thing. And the second thing, we'll try to remove this play and make this play as black as well. Okay, so we'll see how to do that. So basically, I think the threshold for that play button, play text is maybe 0.3. We'll first try that and then we'll make the, oh my god, I think this area also had some red component. So now everything has become black. So we'll leave it now. What we'll do is we will be basically making these this X visible even if the red is made black. Okay, so basically you understand, right, why the red is becoming, sorry, the white is becoming black. It is because white is 1111. So the first component, that is 1, means the first component's value, that is R, is 1 there. So for red also that is 1 or maybe more than 0.5, because we are checking here 0.5, we were checking here 0.5. So it was more than 0.5 for red also, and for white also it was more than 0.5. That is the reason it was becoming black as well. So now first thing that we will check is return color dot r is greater than 0.5. Now, well, it is just like normal C# programming, what I'm doing. Dot b is smaller than 0.8. So basically we just had the white color that we had to remove. So for that white color, all the components are 1. So for the white color, even b will be 1. So it will not be less than 0.8. So now this condition will be met by the uh, red pixels, but not the white pixels. Or let's see if that is the case. So now our target was to make the white visible. So see, here the red pixels have become black, but the white pixels have retained their color. Okay guys, thank you. I may be making more videos about C# event shaders. Please subscribe the channel if you found this helpful. Thank you.